I was going to make this video like a month ago, but then a distraction appeared in the form of palette swapping, and I went and did that instead, so we're going to make this video now. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and it's time to talk about deferred rendering in GameMaker again. So last we left off in the wonderful world of deferred rendering, we were talking about transparency and the challenges that present themselves when you try to do transparency in a deferred renderer and the different ways that you can work around that. Today, I believe the next logical place to go after that would be the subject of shadows in deferred rendering, and that is what we're going to be working towards today. So what you see on the screen right now is a test project. This is what we'll have towards the end of the video. If you've worked with shadows in 3D before, you probably have a decent guess as to what's coming. If you've worked with shadow maps, and if you've worked with, in particular, I'm going to be dealing with directional light shadows because the math is a little easier. You probably have a pretty good idea of what sort of transforms and coordinate spaces you have to do to make this work, and like what textures you have to sample to like get data from the shadow map and that sort of thing. But if you're doing a deferred renderer, and especially if you're doing a deferred renderer where all the lighting calculations are done in view space like I'm doing here, figuring out exactly where and on what numbers you want to do that math on might be a little bit more of a challenge. So I will say straight off that I have seen a few different ways of doing this when I was looking around on the internet for material on this. And I'm going to be going with what I consider to be the most straightforward way of doing this, which is to encode information about shadows in part of the geometry buffer. As with shadows themselves, there are other ways that you can do this. I don't want to make it sound like this is the only way. If you're not familiar with how shadow mapping works in general, I've made several videos on that in the past. I'll have them linked on screen and in the description of the video. I don't want to spend a lot of time retreading old ground here. So, in the project that I'll be working with in this video, this is pretty much where we left off when I talked about transparency. I did go and strip out some unnecessary stuff. So like I was rendering the view space position of the scene to part of the geometry buffer basically as a debug output, but we don't actually need that, so I got rid of it. And there was some other stuff that wasn't really being used, so I just cut it out so that it wasn't cluttering up the project. I also went ahead and threw in some code for rendering the shadow map itself from the point of view of the directional light. Again, I don't want to spend a lot of time going over the basics of how shadow maps work. We will be drawing the scene from the point of view of the directional light, like this. This should look very familiar. This is going to be done, I believe, in the beginning of the draw event of the camera. You could put this in like pre-draw if you'd like, or like draw begin or something like that. It doesn't matter, as long as it exists. So, the first thing we're going to want to do is I'm going to want to go and initialize another surface. And I'm going to call it gbuff_shadows. We're going to initialize that to -1 in the camera's create event. We can go into pre-draw and we can do all the things to make sure that that surface exists. Surface_validate is a handy function which I like to include in my project. This is just going to make sure that the surface exists and that it is of the correct dimensions, because GameMaker is picky about that. So we're going to make sure that the shadow map surface exists, or the GBuff shadow surface exists. I'm going to have to learn to differentiate between those two now. I'm also going to want to go into the regular draw event of the camera, and I'm going to want to make sure that gbuff_shadows is set to multiple render target index 2. So the primary render target is, of course, the diffuse color information. We've also got normal information. We've got depth as part of the depth buffer that goes with the diffuse color information. And now we also have the a surface which is going to contain shadow information. And for some form of debug output, let me go and draw this on the screen at the very end with the rest of my geometry buffer. And we can draw that at basically below the other two. So if I were to run the game now, it's going to look something like this. We've got diffuse color information, we've got view space normals, and we've also got a black screen because we're not writing anything to that yet. So that's our geometry buffer. We're also going to let's see. When we draw the scene in the geometry buffer, so that we can actually do something useful with the shadow map data, I'm going to want to go and... Where's the gbuff shader? I'm going to write some things which might look a little bit familiar to you, assuming that you've done shadow mapping before. So let's say uniform mat for... let's say u light view mat. Let's say uniform mat for u light proj mat. I'm also going to want a couple of extra varyings so that we can pass information from the vertex shader to the fragment shader. I can say varying float v light distance and varying vec2 v shadow text chord. Speaking of things that aren't used, is vs position. That's not used either, is it? Because that was... I forgot to get rid of that earlier. We can just pretend that doesn't exist. Okay. So we're going to need to do our usual transformations to get every vertex position from object space into shadow map texture coordinate space. And again, this should look pretty familiar if you've done shadow mapping before. We can say vec for world space is going to equal gm underscore matrices matrix world multiplied by the object space coordinate. We can go into shadow camera space. We can say vec for shadow camera space, or shadow view space, I guess, by multiplying the shadow's view matrix, the view matrix that the shadow map was rendered with, by the world space position. We can work out the objects or the vertex's position in shadow screen space by multiplying the light projection matrix by the shadow view space value, like this. We can work out the distance of the vertex to the light source's position by saying shadow screen space dot z divided by shadow screen space dot w. And we can lastly work out the shadow texture coordinates by this is going to be a bit more of an elaborate expression, by saying shadow screen space dot xy divided by shadow screen space dot w. And we're going to want to map that into like texture space by multiplying that by 0.5 and adding 0.5. And that's going to transform each vertex like to some coordinate on the shadow map texture. We did that again. We did that when we were doing shadow maps for the forward renderer. Of course, you can make this a little bit simpler by pre-multiplying the light view and projection matrices together outside the shader, but it seemed a little bit easier to talk through by doing it this way, so we're going to just leave it as it is. I'm going to want to carry these two varyings over to... Oh, did I also forget to like delete like my first attempt at this from this fragment shader? It looks like I did. That's awkward. Pretend you didn't see that. Anyway, so in the fragment shader of the geometry buffer pass, I am going to sample from the shadow map texture coordinates, so I'm going to want to supply that to the geometry buffer as a sampler. Now, the point of the geometry buffer in deferred rendering is to do as little work as possible, so that information that isn't relevant to the final scene doesn't have to be calculated. I'm going to violate that a little bit by sampling from the texture map of the shadow map, by sampling from the shadow map in the geometry buffer fragment shader, but we're not, aside from a single texture lookup there, we're not going to do like a ton of work. We're just going to add a few fairly simple lines of code. So the first one, let's say vec for, really, I don't need a vec for, I can just say float shadow depth value. And for this, we're going to texture 2D. We're going to sample from the shadow map at the coordinates of the shadow texture coordinates. And we only care about the dot red of that. We don't need any of the other values in that texture map. let's define a little shadow map bias value here. And we can say if the shadow light distance is greater than the shadow depth. This is why I copy and paste every single variable name, because I don't trust myself to do it right if I have to write it twice. We can say if the light distance is greater than the shadow depth value plus the shadow bias value. Let me just define another float outside of this that's like something float in shadow. Let's do the opposite. Let's assume you're not in shadow, unless you're unless the distance to the light is greater than the distance on the shadow map. And if this condition is true, we can say in shadow equals 1.0. And lastly, gl underscore frag data index 2 is going to be a vec4, what number was that? Vec4, composed of in shadow, which is going to be either a 1 or a 0. That's red. Green is going to be 0. Blue is going to be 0. And alpha is going to be 1 so that it doesn't blend. And this should give us a black and red image, which is going to appear on the screen. It is not going to give us a black and red image, which is going to appear on the screen. Am I staging this when I'm drawing it? Oh, I'm not actually setting the uniforms that I need to actually get the shadow map information on the screen, am I? Let's say samp shadow map is going to be equal to sampler shader get sampler index. The shader is that one. The sampler index is, at least I assume that's what I named it. We can texture set stage to the shadow map sampler, and we can use the texture of surface get texture from, I believe it's just that, from the shadow map surface. We can set that. I'm also going to want to set the light view and projection matrices. And what are those called? Those are just going to be light view mat and light proj mat. All right, I'm being very inconsistent about whether or not we're using the self prefix. Feel free to ignore those if you don't like the self prefix, but we can also say var u light view mat equals shader get uniform, like that, and we can shader set uniform float array. We can set the matrices to the shader as a uniform using u underscore light view mat, and also I've already forgotten what I called it. Oh, it is just light view mat. It wasn't appearing in the code help, so I didn't remember. And we can do that also with the light proj mat. So we're going to set the lights view and projection matrices to the shader. We're going to set the shadow map texture to the shader. And now we should actually have something being drawn down here at the bottom of that gbuffer stack. So areas that are in black are going to be like not shadowed, and areas that are red are going to be shadowed. It's the reverse of what you probably noticed in the at the beginning of the video in the sample project. I just did it the other way around in that one for some reason. All right, so we're halfway there. Let's commit our changes. Just because that feels like an appropriate place to do so. So now that we're done with the geometry pass in the deferred renderer, we can start putting this information in the like the combined step of the deferred renderer. So let's go into the post-draw event where everything is going to be put together, and we can say sampler depth, sampler normal, and sampler shadow. And we can get the sampler index of the shadow map. I don't think I've actually set that up yet in the deferred shader. So let's go and do that after this. We can texture set stage, the shadow map sampler, the tongue twisters. The shadow map sampler, we can say surface get texture gbuff underscore shadows. If we go into the combined step of the deferred renderer, uniform sampler 2D samp underscore shadows. So now that's part of this. I don't believe I have to set up anything else in the post-draw event here, like all the lighting uniforms and the values that you need to go from the depth buffer to like view space. I think that's all I still need here. The transforms with the light positions and stuff. What I am going to want to do is in the actual main function of the deferred combined shader, let's say, again, I'm only going to really need the red channel off of this shadow map sampler. So, not the shadow map, like the shadow data sampler. Anyway, let's say float color underscore shadow is going to be the value when you sample off of the that part of the geometry buffer. And again, we're just looking at the red channel because it's really at this point just like a single true or false. And all the way down at the end, after the rest of the lighting calculations, I can say final. Let's do it this way. Let's say if color underscore shadow equals 1.0, final color times equals 0.5. And this is going to give us a basic shadow effect. It is not going to give us a basic shadow effect. Oh, you know what I'm doing? Again, this is why I copy and paste variable names instead of writing them out. Uniform sampler 2D samp underscore shadows plural, and what I set in the post draw is samp shadow singular. All right, good job, me. I wasted my own time. Let's uncomment that and go back to this. So this is going to, if you spelled all your variable names right, this is going to give us some basic rudimentary shadows. It looks really weird with like 2D sprite characters rather than 3D geometry, but we can see that we've got all the shadow related effects that you might expect from you know, shadows in a forward renderer. That includes, like, if you really zoom in, I can't zoom in farther than this, but, like, depending on the resolution of your shadow map, you might have aliasing. You can see that, like, in locations where that rainbow cube is really distracting, let's go over here. In locations where, like, one piece of geometry meets another based on your shadow map bias value, you might have a little bit of a Peter Panning there. That's not unique to doing shadows in deferred rendering. It's one of the limitations / trade-offs that come with shadow maps in general. Let's see. So that's really all there is to this very basic way of doing shadows in deferred renderers. Again, you can, if you really want to math it out, which I kind of don't want to, you can take these transforms and you can take it from the geometry buffer pass and you can work out a way to do it in like the combined pass of the deferred rendering. While it's not exactly elegant to store shadow information like this in the geometry buffer, I don't think it's actually like more efficient to do that here in the combined pass, because you do actually have to do more work to go like from view space position here to like work out the position of each fragment on the shadow map. Whereas doing it here just means that you have to do a couple of matrix multiplies in the vertex shader and then basically just store value in the G buffer. The math to do this in here, at least as far as I was able to work it out, is definitely a lot uglier. What else is there? I think I said this before, but you can like pre-multiply a couple of these matrices in GML before you set the uniform, and you can save a little bit of work here. Because when you multiply a series of matrices together, you can just do that. And I don't think I talked about this really like in depth in any of my shadow mapping videos, but you can like smooth out edges of shadows a little bit by like taking multiple samples of shadow depth and like interpolating between them. But that's again, that's general shadow map stuff. So I think I'm going to end it off here. If you want the code for this, look for the GitHub repository down in the description of the video. That was less changes in the second half than I really expected. Anyway, next time, and this might or might not be the last deferred rendering video that I make, depending on if I find anything else that I think is interesting after this, but I would like to talk a little bit about how you can optimize this for lots and lots of lights, because that is, well, one of the selling points of deferred rendering is that it makes it easier to do things like that. Until then, my name is Michael, I like wizards and dragons and making games. I like to post videos on the weird stuff you can do in GameMaker, so if anything like that appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all go check out Wizarducks and the Lost Hat, which is the game that I like to work on when I'm not doing YouTube stuff. Link to that can be found down below. I hope you all found this useful, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, Spy Die Games, Manta Ray, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.